We will start our problem with a square. Then, from the bottom left corner of the square, we will construct another square with the area of 20. And on the remaining part on the top left of our square, we will construct another small square with the area of 5, as you can see on the sketch. Now, from the bottom right corner of our big square, we will pull a line which goes through the top right corner of the bigger inner square, as you can see on the sketch. And from it, we will construct another perpendicular line which is equal to our previously constructed line and which goes through the upper right corner of our big square. Now, using those two lines, we will construct another tilted square, as you can see on the sketch. The question is, can we somehow calculate the area of this tilted square? So, if you guys want to try this one out for yourself, you can pause the video right now and then come back and check the solution. Alright, so let's solve this one. So first, let's take a look at the small inner square on the top left. We know that the area of the square equals to the side squared, and we know that the area of our blue square is equal to 5. So this means that the side of this square must be equal to square root of 5. Now, in the same manner, let's take a look at the square on the bottom. It has the area of 20. And since we know that the area is side square and that our area is 20, we can easily say that the side is equal to square root of 20, which we can simplify to 2 square root of 5. And in this way, we got the side of this square as well. Now let's have a look at this interesting orange triangle, which is formed by our bigger inner square and our tilted square. This is right-angled triangle. We know this for a fact because its legs are formed by the sides of the square. We also know that the height of this triangle equals to the side of our bigger inscribed square, which is 2 root 5. And now if we take a look at the side of our biggest square, we can see that it consists out of 2 segments with the lengths of 2 square root of 5 and square root of 5. So if we take a look at the bottom side of this square, you can see that we already have the length of 2 root 5, which means that the remaining length must be square root of 5. But this length also represents the base of our orange triangle. Now, if we label the hypotenuse of this triangle as c, we can easily calculate this hypotenuse by using the Pythagorean theorem. So, c squared will be equal to square root of 5 squared plus 2 square root of 5 squared. And if we simplify and calculate, we will get that c squared is conveniently equal to 25, which means that c must be equal to 5. Alright, but now let's have a look at another triangle. A triangle which is formed by our biggest square and our tilted square. And we know that this triangle must also be right-angled triangle, since both legs of this triangle are actually the sides of the square. Another thing that we can calculate is the hypotenuse of this triangle. If you take a look at the height of our biggest square, you can see that it also represents the hypotenuse of this yellow triangle. And since the side of this square consists out of 2 segments of 2 square root of 5 and 5, we can easily add them up and get that the hypotenuse of this yellow triangle must be equal to 3 root 5. Now let's try to prove the similarity of those 2 triangles. We can easily do this by using the angles in parallel lines. Just as a quick reminder, the identical angles in parallel lines have 2 variations. The first one represents the alternate angles, and those angles are formed in the shape of a letter Z as you can see on the sketch. Another variation is corresponding angles, which are formed basically as the shape of F. So as you can see on our sketch on the left, we have the shape of Z. So, since we know that those two vertical lines are parallel, since those represent the side of the squares, we can conclude that their acute angles must be identical. Now, if we go back to our original sketch, we can see that this means that two acute angles of our two right-angled triangles are equal. This means that their third angle must be identical as well, and those two triangles are in fact similar. So now we can just isolate those two triangles and rearrange them so that they have the same orientation. Now, using the sketch, we can say that the hypotenuse of our smaller triangle is 5 and the base is 2 root 5, and the hypotenuse of our bigger triangle is 3 root 5. But if we label the side of our tilted square as S, you can see that this side also represents the base of our bigger yellow triangle. So we can also label this on the sketch on the right. And now we can use the rule of similarity. We can say that the relation between their hypotenuse is equal to the relation between their base. And if we cross multiply this, we will get the following. From this, we will get that 5s is equal to 30, which means that s has the length of 6. Now, remember, we're looking for the area of the red square with the side of s, so the area must be equal to s squared. Now, if we substitute the value of s, we will get that this area equals to 6 squared, or the area must be equal to 36 squared units, and this is our solution. So, I really hope you guys enjoyed this problem. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this. Of course, if you found another way to solve this problem, please write it down in the comment section below, as you always do. And until next time, see you all and take care.